All right, implicit differentiation. So far we've only taken the derivative of equations that are in the explicit form, where the y is all by itself. So the y is definitely an explicit function of x, but implicit means that neither one is the dependent or the independent. And so this is called the implicit form. I want to show you how we're going to do this. So I'm going to compare doing the same problem in two different ways. So the first is our traditional way. If we just took the derivative of this, we would just say, oh, that's just dy over dx, that's a y, equals power rule 6x, and then negative 5 would just be 0. So there we'd be done, right? If we were to do this same problem implicitly, which wouldn't work well for this problem, it wouldn't be the best way to do this problem, but it still works, we'd do this. We would say, what is the derivative of just y? Well, if it's just y all by itself, then it's just dy. And what is the derivative of 3x squared? Well, that is 6x dx. And this is still 0. Well, now we notice we have a dx over here. We could go ahead and we could divide by dx. Divide by dx. Cancels out over here. And then you would have dy over dx equals 6x. Okay, that's implicitly, where you take the derivative of each variable independently, and then you solve for dy over dx. So let's see some other problems where we need to do that. So here's one. Notice this is the equation of a circle, and notice no form here is the independent or the dependent. There's nothing for us to. There's no one that we're like that's the input and one that's the output. They're both kind of independent here. So we're going to take the derivative of this thing implicitly. So what's the derivative of 2x? Well, or I'm sorry, x squared is 2x dx, and the derivative of y squared is 2y dy, and the derivative of 16, of course, is 0. All right, so we want to get. I apologize, this should have been dy, I wrote it wrong. We want to get the dy on one side and the dx on the other for now, and I'll show you how we do that. We're just going to subtract this whole thing, so we end up with 2y dy equals 2x, negative 2x dx. All right, now to get the dx underneath the dy, we're going to divide both sides by dx, and that'll cancel out the dx over here. Now I just need to get rid of this 2y, so I'm also going to divide both sides by 2y, and that'll cancel that out there. And so I'm left with dy over dx equals, these 2's can cancel out as well, negative x over y. So that's it. Now we found the derivative. It's a little bit tricky, right? Because we're doing them independently, and then we're going to use algebra to get dy over dx. All right, here's a similar problem. And this x times y is one that you're going to see a lot. So we're actually going to see a pattern here that you're going to want to get in the habit of doing. If you think about this, this is really the product rule, because this is two things multiplied together. So let's go ahead and go for it. The derivative of x is not just 1 now. Now it's dx times y, that's a times, plus x times the derivative of y, which is dy, equals the derivative of 1 is 0. All right, same thing. We're going to try and get this the part with the dx on the other side. So we get x dy equals negative, and let's actually say y dx. That's a little bit better. This pattern here is the one that you're going to see a lot, because you'll often see x being multiplied by y in implicit derivative problems. Okay, so we're going to just go ahead and divide both sides by dx. My d looks really funky. And that gets rid of the dx over here, and we're going to divide both sides by x. And so we end up with dy over dx being equal to negative y over x. Pretty cool. All right. So those are two types of problems that before we wouldn't have been able to take the derivative. And now we can. All right, let's go to the next page. All right, look at this guy. So we're going to take the derivative of this implicitly. So let's just go ahead and go for it. It's going to be using the power rule. So this would be 3y squared dy plus 2y dy minus 5 dy minus 2x dx equals 0. Okay, this is the only one with a dx in it, so I'm going to move that to the other side by adding 2x dx to each side. And over here, all of these terms have a dy in it, so I'm going to factor out that dy. And if I factor out the dy, I have 3y squared plus 2y minus 5 left on the inside. Divide both sides by the dx. That gets rid of this. And then I'm going to need to divide both sides by this whole term so I can get this over on the other side. So that gives me dy over dx equals 2x over 3y squared plus 2y minus 5. And now we have the derivative. It's funky, but it works. There we go. All right, why don't you guys just give this one a shot on your own? You can probably figure it out, but give it a try, and then maybe pause the video, work on it, and then unpause the video when you're ready to check your work. All right, so if we take the derivative implicitly, we get cosine x dx. We get negative 2 sine of 2y, chain rule times it by 2 again, dy equals 0. It's negative 2 because remember the derivative of cosine is negative sine. And if we clean that up, that's like saying 4 sine of 2y dy. If I just move this to the other side, I'd get positive 4 sine of 2y dy. Well, once I move to the other side, it's positive. I could just flip sides, no big deal. Equals cosine x dx, and I just get the dy over dx and get everything else on the other side of the equation, and I have the derivative, cosine x over 4 sine of 2y. Okay, let's go to the next. See you on the next video.